Hey guys, what's going on? It's Dave from Evil Eye Games. In today's video, we're going to go ahead and we're going to add an aiming feature into our game. And what I want to do with this is in the Anim starter pack, there are animations for the character to hold the weapon up to the iron sights. So I want to go ahead and set it up so that the character, when we hit the aim button, goes ahead and draws the weapon up to his face and looks like he's aiming down the sights. And secondly, I want to go ahead and create sort of a zoom effect with the camera. So in order to accomplish these things, we're going to go ahead and follow our standard procedure as always. And we're going to start off by going to our project settings, because we have to go ahead and create an input to let the player tell the game that he wants to aim. So we're going to go into our input, and we're going to go ahead and create another action mapping. And I'm just going to call this the aim button. And then for the buttons here, I'm going to add another action mapping group here. So for the first one, I'm going to make it the mouse right button, which is pretty standard fare for shooters on PC. And then for the controller, I'm going to select the gamepad. And usually it's the left trigger button that does aiming. So I'm going to go ahead and select the gamepad left trigger. So now that we have that set up, we can go ahead and exit out of our project settings. And we're going to go into our character and our player character blueprint. And as before, we're going to go ahead and call upon the event generated by the game engine when we click on that button. So we're going to right click and search for the aim button event. And so in order to track that the player wants to aim, the first thing we're going to have to do is create a variable. So we're going to add a new variable in here. And I'm just going to call this is aiming. And all this variable will do is track that the player wants to aim. And so we're going to go ahead and I'm just going to drag this out onto the graph to set it. So I'm going to use our quick Alt key and drag out to set it. And I'm going to duplicate it. And we're going to plug it pressed into one and released into the other. And then when we hit the press button, we want to set is aiming to true. So I'm going to check that box. And when we release it, we want to set it to false. So we want the box to remain empty. So at this point, I'm going to go ahead and compile and save this. And we have to set up some animations too. So I'm going to go back into our main window. And inside of our Anim starter pack, I'm going to go into the folder we created for blend spaces. And we need to create an iron sight blend space for the crouching position, an iron sight blend space for the walking position. And we already have these kind of made. So I'm going to actually copy each one of them. So I will just right click on the crouch hip. And we're going to duplicate it. And I'm just going to rename this to crouch aim. And then I'm going to do the same thing with the walk hip. I'm going to duplicate that. And I'm going to call it the walk aim. And we're going to have to go ahead and set these up with the aiming animations. So I'm going to start with the crouch aim. We're just going to double click and open it up. And in our asset browser, we're going to go ahead and search for our iron sight animation is what they're called. So if we just search for iron, it's going to have a series of crouching animations here for having the iron sight up. And it's going to have a series of walking animations with the iron sights. So since we're starting out with the crouching position, I'm just going to go ahead and I'm going to select these animations at the top here and delete them out. And then over to the right here, we're going to look at our crouch idle rifle iron sights. We're going to put that at the bottom. But first we're going to put the walk forward. And this is going to be the same exact setup that we've done multiple times already. So the walk forward iron sight will go in the center. The walk left iron sights will go to the left of the center line. The walk right will go to the right. And the backwards we'll put in each one of the top corners. And then we have to replace the animations at the bottom with the iron sight animation. So I'm going to go ahead and select each one of these and delete them. And once again, we're going to find the crouch idle rifle iron sights, and we want to drag one of these into each position at the very bottom of the graph. And so if we hold shift and left click, we can go ahead and see that our walking animations work. And we're going to leave the speed at 250. The animations for having the iron sight in the crouch position, as well as not having the iron sights, are the same. So the animations pretty much play at the same rate. There's no real distinction there. So I'm going to go ahead and hit save, close this. And back in our main window, we're going to have to open up the walk aim animation that we just created, or the walk aim blend space. And we're going to do the same thing. So in the asset browser, we're going to search for the iron, and we're going to use the standing animations this time. So at the top, I'm going to go ahead and delete these animations out. And then same thing, we're going to use the standing walk animation. So the walk forward is going to be placed in the center, the left to the left division, the right to the right division, and the backwards to the top corners. And then same thing with down below. I'm going to delete these out. And we're going to go ahead and add the standing idle animation, which is the idle rifle iron sights. So I'm going to add that into each position at the bottom of the graph. And the one thing I am going to note that's going to be different with this set of animations is if we hold shift and move forward, the walking animations with the iron sights actually play slower than the standing walking animations. So the character will actually move slower when he's aiming than if he's firing from the hip or moving with the weapon at the hip. So in order to compensate for this, over to the left in our asset details here, I'm going to change the maximum axis value of the speed in the vertical axis. So I'm just going to set this to 250. And I'm going to go ahead and hit save. And this is also going to add an interesting mechanic for the player so that when the player is aiming, they're going to have a more accurate shot. And we're going to set that up when we get to making the weapon. But the player is going to be more accurate with the weapon when they're aiming. But they're also going to have a downside of you can only move so fast when you're aiming. So that creates a bit of an interesting mechanic for the player when they play the game. So we're actually done with this now, and I'm going to go ahead and close out of this blend space. And I'm going to head back to our blueprints folder with our characters, and we're going to have to go into our anim blueprint. So I'm going to go ahead and open up our anim blueprint. And we're going to have to go ahead and get that is aiming variable. So at the end here, after we cast to our player character, we can go ahead and drag off, and we want to get is aiming. And as usual, we want to go ahead and promote this to a variable, and I'm going to call it the same thing, is aiming. And we can just simply plug this into the end of our chain here. And I'll throw another rewrote node in here to keep it easy to read. So I'm going to go ahead and compile and save this. And we're going to head back over to the anim blueprint. So we're going to look at our state machine here. Now we have to think about adding this in. And we could do something like add in new states, but we already have states that are for when he's standing and idle, and when he's walking and he's standing, when he's crouched and he's idle, and he's walking and he's crouching. So we're going to introduce a new node in here that is going to go ahead and pick a blend space for us in each one of these states. So I'm going to start in the idle standing state here. I'm going to double click that and open it up. And I'm going to right click in an empty section of the graph here, and we're going to search for blend by bool. And there is a node in here that's called blend poses by bool. It's going to look exactly like this. And we can go ahead and drag the is aiming and plug it into the active value. And what this is going to do is there's a true pose and there's a false pose. So what's going to happen is when is aiming is true, it's going to play whatever is plugged into the true pose. And when is aiming is false, it's going to plug whatever's in the false pose. Now, if is aiming is false, we want to play what we were doing before, the idle rifle at the hip. So I'm going to take that animation and plug it into the false pose. And we're going to have to find the idle for iron sights. So I'm going to search for idle iron. And we have the idle rifle iron sights animation. I'm just going to go ahead and drag that out. We're going to plug that into our true pose. And then finally, we just take the output here and plug it into our result. And that is going to have it so that our player blends between states. And we can, as always, test this out. Now, we've only set up the idle for standing, so that's the only place it's going to work right now. But if we go into play, and I go ahead and right-click, he brings up the weapon and goes into the aiming down the sights animation. But I want to create a little bit of a blend in between having his rifle down and bringing it up, so it looks like a little bit of a smoother animation. So we have these blend times in here. And I'm going to set these to, let's say, 0.25 on both of these. So what these blend times are going to do is it's going to create a blending between one animation and the next so that it appears a little bit smoother. So if I compile and save and hit play again, and I'm going to go ahead and click into the window, and if I right click, you'll see that the animation makes a more smoother blend, and it actually looks like the character is bringing the weapon up to aim down it rather than just immediately popping it up towards his face. So that'll create a better visual for the player, and it will just look better in general. So now we're going to have to do the same thing for the rest of our states with our crouching and the other two blend states that we have. So we're going to head back for the idle crouched. It's going to be the same exact thing. So we're going to right click, search for blend by bool, if I can spell properly. So we'll select the blend poses by bool, plug is aiming into the active value. The idle rifle hip will go into the false pose. And the crouch idle rifle iron sights, that's quite a long name there, that's going to go into the true pose. We're going to plug the output into our final animation pose, and we're going to set the blend times to 0.25 on both of these. And then we're going to head back to our animation state. We're going to do our walking standing. So for this one, same thing. We're going to search for blend by bool. We're going to go ahead and plug is aiming into the active value. Hopefully you're seeing a common thread here. And our walk hip is going to go into the false. And then we're going to have to search for the blend space. So I'm just going to search for BS. And we're going to have to take the walk aim animation. And we're going to plug this into the true pose. We're going to plug the output into the final animation pose. Set our blend times to 0.25. And this one is going to be just slightly different in the fact that we have inputs here. So I'm just going to go ahead and drag off of our already existing gets for these variables and plug direction into direction and speed into speed. And that is going to go ahead and complete our walking standing state. And then we're going to have to do the walking crouching as well. So once again, same exact thing. We're going to search for blend by bool. Plug is aiming into the active value. Plug our crouch hip into the false. And then we'll get our crouch aim and plug this into the true pose. Plug the output into our final animation pose. Set our blend times to 0.25. And then we're going to share these variables. So we'll plug direction into direction and speed into speed in the crouch aim. And I'm just rearranging here because I'm a little bit of a neat freak when it comes to this most of the time. And we can go ahead and compile and save. And let's go ahead and test it out. So if we hit play, if we're standing still and we hit the aim button, he brings up the weapon to aim. If we go ahead and crouch down and bring up the weapon, he will go ahead and bring himself into the aiming position. And if we start moving around while standing, he goes ahead and aims. Now, we haven't set the speed, so it'll look like his feet are sliding around, but we'll get to that. And then if we crouch while we're moving around and bring up the weapon to aim, he goes ahead and does all that. So, everything is looking pretty good in this case. Everything is working as it should as far as our animations go. So at this point, we can close out of the anim blueprint, and we're going to have to take care of some of our stuff in the player character. So the first thing I'm going to go ahead and take care of inside of the player character is updating the walk speed, because when we're aiming, we need to slow the character down. And luckily for us, all of the crouching speeds and the aiming speed are going to be the same. So we're going to want to use our update movement speed function that we created before, but we're going to have to go ahead and make some modifications to it. So I'm going to go ahead and open up our update movement speed. We're going to double click on the function, and it'll show us the graph for that function. So now we're going to have to think about how exactly do we want the movement speed to take priority when making decisions on how fast we're moving. Right now, we just have is sprinting, so that's really simple, but we have to think about is aiming, and we want to think, is aiming going to override is sprinting, or is sprinting going to override is aiming? So for this case, I'm just going to grab all of our is sprinting, and we're going to drag it off to the side. I'm going to set this up so that is aiming is going to take preference over is sprinting. So from our update movement speed here, I'm going to drag out, and we're going to go ahead and insert a branch. And I actually want to disconnect this pin here, so I'm going to right click and break link to branch. And we're going to go ahead and plug our is aiming into the condition. So the first thing we're going to check is we're going to see if the character is aiming. Now, if it's true, we're going to want to go ahead and set the maximum walk speed. So I'm here, I'm going to literally just copy one of these set max walk speeds. And we're going to plug true into this set max walk speed. And the aiming speed that we have is 250, so I'm going to punch in 250 for the max walk speed. And we're going to have to connect this character movement node up to it as well. So I'm going to go ahead and I'm going to drag out and plug into there. And then if we are not aiming, we can go ahead and hit false to plug into this branch. And I'm going to go ahead and just rearrange some of this to clean it up and make it easier to read. So let's say I'm going to put in a branch down here, or a reroute node down here. And then I'm going to plug off of this reroute node to plug into that set max walk speed. And then this node right here is fine. So what we're doing here is when we go to update the movement speed, we're going to check first if the character is aiming. If the character is aiming, we're going to cap the maximum walk speed to 250. If we're not aiming, we're going to go ahead and we're going to check to see if we're sprinting. If we are sprinting, we're going to set our maximum walk speed to 750. And if we're not sprinting, we're going to set it to 500. And that's going to pretty much take care of all the use case scenarios for the different states that our character can be in that are going to affect their speed. So I'm going to go ahead and compile and save this. And we're going to go ahead and go back to our event graph. So right after we go ahead and perform our action where we set is aiming, we're going to want to go ahead and update our movement speed. And I'm actually going to duplicate this. So there's going to be one for each here. And there's going to be a particular reason I want to do this, which we're going to get to next. Normally, if you didn't have anything following these update movement speeds, you could go ahead and plug each one of these into just one update movement speed. But now I want to set it up so it does something a little bit different based on whether we're aiming or we're not aiming. And what I want to do is create a zoom effect. And that zoom effect is going to be based on whether or not we're aiming or we're not aiming. So hence we're going to need separate leads coming off of these update movement speeds, because we're going to want to have a zoom in effect when we're aiming, and we're going to want to have a zoom out effect when we're not aiming. So in order to do this, I'm going to introduce another thing. We're going to go ahead and right click in the graph and search for a timeline. And at the very bottom here, you're going to see an add timeline. And we can go ahead and name this. I'm going to call it the aim timeline. And what an aim timeline does is it's kind of like a play track. And we can create variables within it. And what it's going to do is as the timeline plays from start to end, it's going to change a value for us over the course of the timeline. So it's kind of like hitting play on a record or an MP3 or something. So basically what we want to do is we're going to plug the update movement speed from our pressed. We're going to plug that into play. And then the other update movement speed, we're going to plug it into reverse. And what this is going to do is it's going to start to play this timeline from wherever it is in the timeline in a forward manner. And the reverse is going to obviously play it backwards. So now we have to actually configure our aim timeline, but we have to understand what we're doing to create a zoom effect. So before we set up the aim timeline, I'm just going to go ahead and we're going to drag out from our camera and our components, and we're going to get a reference to the camera and our character. And we're going to drag out from this camera, and we're going to search for set field of view. And this is going to change the field of view of the camera. Now, to see what this looks like without the timeline, I'm going to break this off here, and I'm just going to plug this into here, and I'm going to create a duplicate. Now, by default, the field of view for the camera in Unreal Engine is 90. So when we're not aiming, I'm going to set the bottom one to 90, and I'm going to set the top one. We're going to create a smaller field of view, which is going to create a zoom effect. So I want to show you what that looks like before we actually implement it. So I'm going to set it to 60. So I'm going to go ahead and compile and save. And if we hit play, I'm going to go ahead and right click, and you're going to notice instantaneously it goes ahead and kind of creates a zoom effect. So it changes the field of view instantly. And I would rather have a zooming in effect rather than an instant change from zoomed out to zoomed in. That kind of looks a little weird to me. So that's what we're going to use this timeline for. So I'm going to replug that in. I'm going to hit play into the aim timeline, and I'm going to go ahead and plug the second update movement from our not aiming into the reverse. And we're only going to need one of these set field of views. So what we have to do is we have to create a timeline now that is going to change the value of our field of view. So we're going to need it to output a float number for us. And we're going to need it to move between the value of 90 to 60. And then when it goes backwards, go from 60 to 90. So to configure the timeline, I'm going to go ahead and double click on it. And you're going to get a screen that looks like this. At the top left here, we're going to hit the add float track. So that'll create an output value for us that's a float. And right underneath it, we'll get to name the track. So I'm going to call this our FOV value. Now to the right of where we added the float tracks, there is this box with length. Now, when we looked at the Anim blueprint and we created those blends, we did it in 0.25 seconds. So I'm going to mirror that here. I'm going to make this track last as long as the blend between when the weapon is down to when the weapon is up. So we're going to set this to 0.25 as well. And if you want to fit this to the screen, there are these two little icons here, so you can zoom to fit horizontally and vertically. And it really doesn't do anything right now. But let's go ahead and we're going to add 2 points to this track. So I'm going to right click, add a key curve, and then we're going to do the same thing somewhere else on the graph, just add key to curve float. And I'm going to left click on this first value here. So this is the start of our track when we're not aiming. So I'm going to set the time at the top here to 0. And then we're going to set the value to our default field of view, which is going to be 90. I'm then going to go ahead and select this second one here, and we're going to set the time in here to 0.25. So that's going to be the end of our track. And we're going to set the value to 60. And then I'll go ahead and zoom to fit on both of these. So you're going to see at the top left here, we're going to have at time 0, it's going to output a value of 90. And at time of 0.25, it's going to go ahead and output a value of 60. So basically when we hit play and we're starting from the beginning, it's going to continually update the value coming out of the timeline all the way until it gets to the end of the timeline. So these are the 2 values that we want to go ahead and push into our camera set field of view. So at this point, we can go ahead and close out of the timeline. And we'll see now that there is a new output on our aim timeline that we named that track. So this is actually pushing out that value of whatever the track reads when it plays. So we're just going to take the FOV value, plug it into the field of view in our set field of view, and then plug the update output into the set field of view. So what's going to happen is every time this updates, we're going to call on the set field of view, and it's going to get the field of view from our field of view track. So this should create a nice smooth transition from the 90-degree field of view down to a 60-degree field of view. So if we hit compile and save and hit play, I'm going to go ahead and click in there. If we click into the graph, it has a nice smooth animation, or at least what appears to be a smooth animation, where it kind of zooms in, and it's not instantaneous like it was before. So now we have our zooming functionality in, and we have the aiming change of animation in as well. So I'm going to go ahead and put a comment box around our aim button here. And of course, I'm just going to call it what it is. It's the aim button. And the one last thing I want to do in this video is I want to go ahead and readjust the camera so that it kind of hides all the animation flaws that we have. So if we look at our viewport here, the camera is basically straight back from the character. So I want to offset this camera a little bit to the right, and I want to bring it closer into his back. Basically, I want to hide his legs. And this is a trick that is very useful in the video gaming industry because you can't always fix everything. Depending on timelines or budgetary concerns, you're going to run into something where there's a problem you can't necessarily fix, but it's not game breaking. So instead of actually trying to spend so much time on fixing something or doing something down the road, it just might be more efficient to hide it because it's going to be something that nobody ever notices. In this case, if we hide his lower legs, it's going to hide the fact that our 45-degree animations to the left, front left, and the back right are kind of messed up. So I'm going to move the position of the camera using the spring arm here. And it's important when you move the camera to use the values in the spring arm, because if I take the camera and go ahead and move it off to the side here, you're going to see that it's offset from the end of the spring arm. So if the camera collides with something, it will start moving down the length of the spring arm towards the player character. But the problem with this is this can actually create some clipping issues because the collision kind of doesn't work right if the camera isn't directly on the end of the spring arm. So I'm going to go ahead and undo that camera movement. We're going to click on the spring arm, and under camera here, there's a socket offset and a target offset. What the socket offset does is it moves the position at the end of the spring arm, so where the camera resides, and the target offset moves where the source of the spring arm is, so where it is at the character. So to set the camera off to the side a little bit, I'm going to go ahead and I'm going to set it to the right, and this is a little weird with this functionality here, but I'm going to set the Z to, well, I'm going to raise it up a little bit. So I'm going to set the Z to 15, and then we want to adjust the value left and right along the Y-axis. So for the Y-axis here, I'm going to set it off. Let's say, I'm going to try 60. We're going to see how that looks. So this is going to place the camera not directly in line with the character. It's going to be offset to the right and up a little bit from where we originally had it. And I want to bring the camera in closer to the character. So right above the socket offset and the target offset, there's a target arm length. And this is going to determine basically how long the spring arm is. So I'm going to drop this down. I'm going to have it. I'm going to set it to 150. So it's going to be much closer to the character. And this should be able to hide the lower half of the character so that we can't see all the messed up animations on his legs. So let's go ahead and compile and save. We'll hit play to take a look at what the camera looks like. And that actually looks pretty good. It's doing a pretty good job of hiding his legs. And it works pretty well when zooming in. So I actually like this a lot. Now, depending on your taste, you can move the camera around. Just remember to use the socket offset and the target arm length here in order to set the position of the camera. And you can play around with it a bit and see if there's some values that you like better. But I particularly think this positioning works really, really well in this situation. It hides enough of his legs so we can't see the jacked up animations going on down there. And it kind of recreates the same kind of look you get from the original Mass Effect game. So I'm a huge fan of that, and I like that positioning. And once again, you can play around with it and see what exactly you like and what works best for your situation. But this is just the position that I happen to like the best. So that's going to complete the video. If you guys have any questions or comments, you can go ahead and leave them down below. I'm also going to leave a link to my Facebook page, so if you want to follow me over there, you can do that. And as always, guys, thanks for watching.